Hello. Hello. Danica. Hello.
Yes, sir.
Can you hear?
Yes, sir. Yes, sir.
Hello.
Hello. I can
Yeah.
hear you, sir.
Okay. 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 Thank you.
Yes, sir.
Good morning, everyone. Hello, good morning. Can you hear me?
Good morning, sir.
Good morning.
Good morning,
Morning,
sir.
sir.
Yes, ma'am. Sir, is there any update from Professor Ahmad Hassan? Hello, sir, I can't hear you, sir. Sir, I can't. Hello, not audible, sir. I, Professor Ahmad Hassan has joined. Sir, good morning, sir. Assalamu alaikum wa rahmatullahi wa barakatuh.
Hello, Mr. Hazab. I switch on your.
You have to unmute.
Hello,
Yes.
Yes,
Hazab,
yeah,
my friend.
yes.
So good early morning.
عليكم السلام ورحمة الله وبركاته.
Assalamu alaikum, sir.
Assalamu alaikum. I feel
عليكم السلام.
so
كيف
early.
حالك شيخ؟ كيف حالك؟
Yeah, fine. Alhamdulillah.
Alhamdulillah. Yes, sir. Good morning. A warm welcome to each and everyone here. Sir,
Yeah.
Professor Ahmad, sir, whether we have to wait for Muhammad Fahim?
Yes, he already joined. He told
joined.
me that he was in. Yeah.
Okay, yeah. Thank you so much. A warm good morning and welcome to one and all here to Architecture Geometry 2021 online webinar organized by CS Architects and Research Lab with its international group and Hindusthan School of Architecture, Coimbatore, in collaboration with HASAB Research Lab and Specialist in Advanced Structures and Digital Fabrication. Today we are going to conduct an online workshop under the concept Learning for Everyone. That is for 2 days on 25th of Jan and tomorrow 26th Jan. We would like to thank Professor Ahmad Hassan for accepting our invite, and I have to thank Architect Chandrasekharan for coordinating, for organizing such an event, and Muhammad Fahim also. And to say a few words about our professor, Architect Ahmad Hassan Muhandis Mamari. He is a PhD candidate, lecturer, research assistant from American University in Cairo. He is a committee member at Digital Futures World, senior architect engineering consultants group ECG. He is a founder of HASAB, specialist in advanced structures and digital fabrication. Apart from, he is an Egyptian architect with over 12 years of Rhino 3D experience, 8 years of conducting computational design and digital fabrication research, and 6 years of doing experimental applications at American University in Cairo. Architect Hasab has been invited as guest speaker to a number of international meetings and conferences, such as the International Users Meeting at Aalto University in Finland, the Young Award Forum in Shanghai, participated in Digital Futures Meeting in Shanghai. Professor Hasab holds a bachelor's and master's degree from Cairo University. He achieved an honors excellent grade in his graduation project. Professor is currently pursuing his PhD. He acquired practical knowledge in design, software, and hardware, 3D digitizing, digital fabrication for industries like architecture, naval design, furniture, and jewelry as well. In addition, he has given training to many teachers, designers from Egypt, Dubai, US, Canada, Netherlands, Morocco, Italy, Algeria, Senegal, Saudi Arabia. For his master's in architecture engineering, he developed 4 Grasshopper plugins specialized in fabrication, data, and extradition for double curved structures. This is a brief about our Professor Ahmad Hassan, and I would like to invite Architect Muhammad Fahmi. He is teaching research assistant at HASAB Research and specialist in advanced structures and digital fabrication, and junior architect at Engineering Consultant Group, ECG. And I would like to welcome Architect Chandrasekharan. host organizer, CS Architects and Research Lab. So first of all, I would like to thank all the participants and all the students who have joined now. Now I request Architect Chandrasekhan sir to say a few words about our instructors, Professor Ahmad Hassan. Welcome, sir.
I'm honored being with you, sir, and with my friend Chandra. Thanks for you and for everyone who is attending our workshop.
My pleasure. Our pleasure, sir. Thank you so much.
Welcome, welcome to Architectural Geometry in 2021. This is a wonderful course for everyone. I hope. Thank you very much, Hindusthan School of Architecture and Coimbatore. It's a very beautifully. You can support it with our international peoples and communicating with others. Azab and Mr. Azab. I never say Mr. Azab. He is one of my great good friend. At the same time, he was an very intelligent and very good researcher also. I have lot of work. I have seen lot of workism, and I can't say words. Anyway, we can continue our classes. Let's talk to Mr. Azab. Azab, and
Yes.
yeah.
Yeah. My greeting from Cairo for Professor Siraf for inviting us, and for Chandra and for everyone attending our workshop, and for our audience everywhere who is listening to us through YouTube channel of the school. Actually, I'm happy being here. We are going to start our presentations with a lot of discussions regarding the digital fabrications. I had actually a lot of presentations for us today regarding digital fabrications, a lot of projects, videos, and so on to interact with and discuss. And then we'll open Rhino and Grasshopper to start giving some technical tutorials. I have Fahmi here. Will be supporting everyone while working on the software if someone has a technical problem and so on. I'll send my email later for Chandra. He has it. He can share it with everyone. If anyone would like to ask about anything or ask for a technical advice, we will be available for everyone. I would like to start sharing my presentation. This is my first time to use Google Meet. I have to mention this. But I feel it's fine. Yeah, I can see, yes, my entire screen. Share now. Share. Yes, Google Meet now. Is it working? Sharing my screen now?
Yes, sir.
So let's start by asking
Hello? Hello, Azab? Azab, hello?
Yes, it was my mistake. Yeah, I closed it by mistake. I hope it's fine. Yeah.
It's okay. First of all, I say
Yeah.
we are both our first time we meet.
I mentioned, yeah, this is my first time. Yeah, I'm presenting now. Okay. So let's start our day by interacting with our students. I would like to hear voices from India now. What is digital futures? How do you imagine digital futures? I would like to hear some answers, and then we can start. What is digital futures? How do you imagine your future and the digital futures in general? Why you are attending our workshop, and what do you expect from us? I would like to hear some voices.
I request our students, dear students, to just cooperate with our professor and please answer. Yeah. Open to all.
Hello, dear students. I would like to hear your voice. Anyone?
Yes.
Yeah.
Yes, please, students. I
You
think
have, you know, I remember I attended a workshop with RMIT in Melbourne, in Australia, and they mentioned that you have to believe in yourself, that you can change the world for a better place, and then you can do it. So, firstly, you have to believe now in yourself that your answer is right, and just try to share it with me and with everyone. Just believe in yourself.
thank you, sir.
Hello, sir. Good morning.
Yeah, good morning.
Myself, I'm Balamurugan. So I guess uh, digital future is right now we have digital architecture where we follow computational designs. So
Okay,
it's basically based on interactive designs and some interactive spatial designs and some performative designs maybe.
great. Yes, yeah. Thanks for sharing.
Thank
I
you.
would like to hear more voices, more ideas. How do you imagine the digital futures? We had around 40 participants. I would like to hear 20 as minimum.
Yes, yes, sure, sir. I'll request the students because Professor Hassab likes to have an interactive session, not like a normal presentation. His way of presentation is completely different. The way we had a discussion that day, I'm very much impressed by his presentation. So I request all the students to keep it as an interactive session. Even the
Yeah.
faculties, architects, everyone whoever is present here, I request them to just share your ideas, please.
Yes, yes, yes. Anyone attending our workshop um, can share his thoughts freely. Um, just share your ideas because this is how, you know, what is digital futures? Digital futures is somehow what we are doing now. What we are doing now. It's 6 a.m. Cairo time and it's 10 a.m. India time, and we are like discussing our futures. I would like to hear more voices. What is digital future from your point of view, and how do you imagine the digital futures? Any participant?
Sir, good morning, sir. Myself, Bharat.
Yeah, yeah.
Sir,
Good
I
morning.
think that digital futures giving more usage in the form like small spaces, sir. Maximum usage in these small spaces. I think that's the form.
Maximum usage of from Mars?
No, sir. If we have the small space, we would like to give
Yes,
many
yes.
usage for that space with the like many elements by
Y-
using many elements.
Yeah. So you mean the digital futures is by reaching other planets and stars and so on, and get benefits from its minerals. This is what you mean.
I yes, sir. It's like
Okay, okay, you know, this is very interesting. This is my first time to have an answer like this. Thanks for sharing.
thank you,
This
sir.
is very helpful. Yeah. Positive vibes in the morning is very helpful. Thank you. More ideas. Do we have anyone would like to share more ideas? More 5 minutes to spend. Hello, my friends. Hello, everyone. Just feel free to share your ideas and believe in yourself. This is how we are going to change the world.
Hello, sir.
Yes, hello, my friend.
So this is Jason. Uh,
Hmm?
So it is to do something with artificial intelligence, which is combined with architecture.
Okay.
So
Very
and adaptive design in accordance to that.
okay. Artificial intelligence is coming. Yes. I have a paper published in a SCAD conference in few days about using artificial intelligence in generative design. Yes, it is somehow very helpful, and we had a lot of sessions in Digital Future regarding the artificial intelligence. You can find them on our YouTube channel. Um, but still, there is some aspects need to be discussed regarding the artificial intelligence, like the ethics of using the artificial intelligence and so on. It can be very helpful and very tricky somehow. But yes, it is extremely coming. Yes. Thanks for sharing. This is, very new type of idea. I'm happy to have it. Yeah. Any other ideas? I'm happy to hear more ideas.
Sure. This is again from Bala. So
Welcome.
yeah. So it's basically when it comes to digital buildings, we can say like they used advanced technologies to enable the flexibility and reliability, and we can use some computational tools like we have to understand the machine language in case of
Mm-hmm.
designing these type of buildings with several iterations.
Okay. Um, okay. So digital tools is about designing buildings with a lot of iterations and optimizing the solution as well. Yes, I agree with you. And can I ask you a question?
Yes, sure.
Why do we learn to use Rhino and Grasshopper?
It's basically works on computer language. So it's basically like we have to understand the computer's language, and we can give several inputs, which gives several iterations to our design, and some
Yes.
organic forms. Maybe we can say like
Yes. So you believe we are going to learn Rhino and Grasshopper to optimize our designs? Yes, I agree
yeah,
with you. But
yeah.
yeah, I would like to add other aspect. We are going to learn Rhino and Grasshopper so we can fabricate whatever what we designed. Usually we can build um, what we can export an elevation, a section, and plan and so on from my geometry. But Rhino and Grasshopper was so helpful, so we can convert these kind of surfaces to a data that the machines can understand and so on. From my point of view, I believe Rhino, the idea of using nervous surfaces and equations in architecture was so helpful in starting this era of building this kind of facades and surfaces and so on. Yes, but optimization is very important as well. Yeah. Thanks for sharing.
Yes.
Any ideas? Any more ideas from more friends? Hello, dear
Hello, sir.
friends. Yeah,
Hello.
welcome.
Sir, myself Aftal. So I think digital architecture will be our future. It will help us build the buildings quickly.
Okay, so you would like to save time
Yeah. For
and
example,
money, a lot of money.
China built a hospital in 3 days due to Corona.
Yes.
So in times of this
Mhm.
urgent and necessary situation, we can build the buildings very quickly, sir. So we can save time and save lives.
Yes. Yes. Very positive point of view. Yes. Yeah, it can be very helpful. Yes. Um, we have a lot of architectures that can be helpful in this perspective, in this point of view, like a prefab architectures and so on. Yes, using the digital fabrication, we can just design and fabricate everything like in a lab, and then we go on the side just to do assembly, just to make everything together. Yes, we can save time and effort. Yeah, I agree with you totally. Yeah, thanks for sharing. Any more ideas, my friends? Just believe in yourself, believe in your ideas, and share it with me and with
Sir,
everyone.
I have some doubts apart from this. Like, I have attended some of the webinars from Digital Futures, but I
Mhm.
can't access some of it. So, why is that, sir?
Um, Again, I'm sorry. So you mean
Like, yeah,
you attended a lot of digital futures webinars, but you
yeah,
can't
but
access some of them?
yeah.
No, no, it's totally available on YouTube. I'll send the link later. And you,
Okay,
if you just opened our website, digitalfeatures.world, you can find everything on the website. And
okay,
if there is anything that you can't reach, just send me a message. This
sure,
is not
sure.
what we are doing. We are just sharing everything. You know, Professor Neil Leach is sharing his PhD, the DDS, in FIU in the US, totally online. He is sharing his discussions online for everyone, his lectures, his weekly lectures. It's available, but maybe you can't reach it. I'll share it with
No,
you. It's fine.
sure, sir. Thank you.
And you have any questions later on this webinar, just send me.
Yeah, sure, sir. Thank you.
Thanks for your interest. Okay, so now, um, after our very short discussion with my friends, I had a lot of ideas, actually, very interesting ideas. Okay, let's start our discussion. Today, I'm here with you to discuss, the future of architecture, and then we'll discuss a lot of ideas regarding the digital fabrication and some technical advices in Rhino and Grasshopper. I'm Ahmed Hasab. As a professor mentioned before, I'm working in the American University in Cairo and engineering consultants group and digital features world. And here you can see my QR code to reach me on Facebook and LinkedIn. And this is my email and my phone number. I have no problem if anyone just sent me a message on WhatsApp or an email or reach me on Facebook or LinkedIn asking about anything or just asking for material advice. I'm available, I'm available 24 hours. This is how we are going to build our futures. It's not just my future, it's our futures. Um, we have to collaborate and cooperate and support each other, working together to build a better future for everyone. So I'm just sharing all my contacts. And I'm happy with it. This is my graduation project. I have done in Cairo University in 2012. And this is made using Rhino for modeling and TSP lines, and then Rhino render. It is totally just made of Rhino. Um, okay, let's go back. What is digital futures? Let's see. Architecture is art of engineering, and this is why architects have to imagine the future. Let's start our discussion by looking on how the architects imagine the future already. We had a famous architect called Sid Med. He is designing the future. He is designing the vision. So he designed a lot of scenes like in the movies and so on, like Blade Runner, Tron Legacy, Aliens, and recently Blade Runner 2049 and so on. And this is how architects used to imagine the future, and this is how you should imagine how to build the future. it is usually starting with imagination. You have to imagine, and then you have to look forward and study more, and then you have to believe in what you are doing and starting to do. This is how we are going to build our futures. Okay. He started thinking of a lot of machines, flying cars, flying cities, responsive cities, and this is can be seen in his, in movies and so on. And this is very old images, very old visionary images. We can see some buildings nowadays designed using these kind of lines. We can see flying drones everywhere. We can see, maybe we can see flying cars in the next few years. We can see a lot of robots talking using AI. They may be conscious. They may be like us. I read yesterday an article on Microsoft. They are designing, like, let's say, an AI, conscious AI, who can represent someone. You can, maybe you are dead, but you still exist like a hologram, so your family can talk to you and so on. Yeah, I believe there is some ethical issues need to be discussed, but they are looking for the future. And Sid made as well. He was designing the future. And by looking for the future, looking for imaginary ideas, looking for technology, this is how you are going to develop a construction technique and so on. This is how, like, great achievement is happening. This is how someone like Elon Musk is building a rocket to go for Mars or for the moon, as some of our friends just mentioned. Okay, so we started by asking ourselves how architects imagine the future. But now it's time to ask ourselves how architects built the current futures. They started building the futures. They started to have a double curved metal surface. They started printing these, and we can just watch now. What we are seeing, we have, like, this is a robotic arm, and this is a 3D printed metallic surface. And then they, I, okay, if someone just sent me a message I don't hear, you have to ask by yourself. Okay. And this is how it is 3D printing a metal surface. It is just like an electric shock between positive and negative charge, and then some kind of metal wire is being melted, and like it is an additive manufacturing, depositing metal in a kind of layers. It is totally as if you are doing a plastic 3D printing, but we are using a metal wire rather than just using a plastic wire. And then you will have a double curved metallic surface. It's very interesting, and it is just very hard surface. And a lot of structural engineering should be done, like, while designing these kind of surfaces. And using Rhino and Grasshopper, we can design this surface and we can build it. But the point is still, we need a competition. We have a computational designers with an architectural background, but the world still needs computational designers with a structural background. So I try too much to reach students in architectural departments, but not yet in our communities. Some communities have, but our communities not so much. Okay, let's move forward. And this is Steel Bridge in Netherlands. They started designing and building and working on this project, let's say, around 5 years ago. And this is a video how they started their imagination. They started, like, thinking of, why not we have like two robots on a rail, and they we can fix them. We can start on a canal, on a river, on something like this, and these two robots will start doing the 3D printing together and building the rail they will be moving on, and the bridge itself. Then finally they will reach the other side. This is how they imagined. This is how the vision was. And then on real, they couldn't make it, but they make it in a lab. Firstly, they started their early experimentation, as we can see here in the video. You know, like we'll see more clear images regarding this early experimentation. This early stage was like a structural stage, experimenting the structural stability and so on of these kind of 3D printed surfaces. And then they started printing like pieces. Yeah, it is downloaded from YouTube, so their copyrights. They had the video. Okay, it's a 40 feet. Okay, and then this is a simulation from the structural engineering and how the vision was regarding starting from both sides, and then we can have this kind of bridge. But as we mentioned, it is done in the lab. And this is the early stage. It is totally a structural simulation and a structural experimentation. They started by 3D printing this very simple structure in the lab, and then they started experimenting and having a user experience and simulating and getting statistics from it and so on. And then they went for completing the 3D printing of the bridge in the lab. And as I know, nowadays they are doing like a material statistics, behavior statistics of the 3D printed object with the user moving around as a live load and so on, to make sure it's fine, stable, and it is safe for everyone to use. And then we can go for Wolf D. Briggs. He is like a visionary architect with a lot of fabricated projects around the world. And Wolf D. Briggs, if we just open here and just went for Google and Wolf D. Briggs, I don't know actually if I'm saying his name, pronouncing his name well or not, but I'm totally recommending for everyone just to check the website of Wolf D. Briggs. He had a lot of very interesting projects, just just fabricated, and you can see it on site. And these kind of projects can't be done if he is not using these kind of nervous modeling softwares, and then he can extract data direct to the machines and so on to work on. And now I have a video about this interesting project, this interesting metallic surface, and how these surfaces are fabricated and assembled on site. Yeah, it's a simulation, and with a very small, like a video clip from the real time doing. At first, it's just a metal sheet, and using a robotics and a vacuum, and then we take it to an adjustable mold. This kind of adjusters, it will like push, and then it will be deformed, and we'll take it, stack these kind of pieces together using the robotics, and then using a to delete. This is how the surveyors are working and taking like the coordinates in real world. And then we have this kind of structure. This structure is in Rhino, we can do it like a contouring. It is just sections. It's just 2D sections, and these 2D sections can be a worldwide grid. It can be a UV mapping for a grid on a double curved surface, and then they can relocate these tiles we seen in the few minutes before. They will be relocating these tiles using the robots on this kind of a UV mapped grid on the double curved surface. And then the robot will be doing the assembly. So this, as I mentioned, this structure, this mesh, was like a UV mapped grid, and these kind of metallic surfaces assembled using the robots and the coordinates in the real world, and then the robots are going to do the welding and so on. After a lot of search on YouTube, this is the only video available for constructing this surface, and it is totally made using the robots. Okay, if we just moved forward in the video, we can see after the welding they are preparing the surface and working to soften the connections and so on, so you can see the connections. And this is how nowadays, if you look on the website, you will see like a continuous surface. If anyone had any questions, just write notes, and by the end of this presentation, I can hear your questions and we can discuss. I have a lot of presentations, but after every presentation, we'll have a kind of a coffee break, so you can get a cup of coffee and have a rest, and then we can discuss your ideas and questions. In this small video clip, you can see the robots are preparing the real-time surface that is built, in the real life, in the real world. This is a real photo. This building is already constructed. Okay, and here you can see the robots preparing the surface in real time and softening and making it very glossy and reflective and so on. Okay, and then moving forward, this is a very impressive idea. This is, let's say it's a skeleton, yes, it's a concrete skeleton, yes, but it's a boat. It's a boat who can be used in a river and so on. Um, let's go for the video. Okay, so this is this kind of skeleton, how it is made. Okay, watching the video, they started using a very innovative way of doing this kind of a skeleton. They started 3D printing the formwork itself. They started 3D printing a negative mold of these kind of skeletons and ribs. And these kind of plastic printed pieces will be assembled together, as we will see in a few seconds. Yes, this is the pieces. It's all 3D printed in plastic, like a formwork. And then all these pieces will be assembled together for the whole boot, and then they will start like pouring the concrete inside. And this is like, we can say it's a computationally designed surface and a computationally designed formwork. And I believe this kind of structure wouldn't be working if they didn't think like structurally. Not everything is just architecture, not everything just a kind of art, but we need some kind of structural analysis, structural optimization. And as some of our friends just mentioned while our discussion at the beginning, while designing a computationally designed surface, an artistic surface, a double curved surface, or any surface that will be fabricated using an automated mechanical process, you need to do a structural optimization. I'll share some thoughts regarding the structural optimization. Yeah, in Egypt, in Cairo, we have two types of architectural schools. We have firstly an architectural engineering schools, and other type is an architecture school, just architecture. I'm from an architectural engineering background. My bachelor's, my master's, and so on. This is why I believe we have to consider the structural analysis and optimization. But when I was a student, I wasn't having this kind of strong belief. But after my research and so on, I discovered that let's say every beautiful design have an innovative structural skeleton behind. So if we don't have an innovative structural designer who can optimize his structure, we can't have a beautiful architectural surface. So we need to raise the awareness of using these kind of computational tools, not just between the architectural students and the architecture professionals, but we need to spread this kind of knowledge between the structural engineers as well, because it is a cooperative process. We need them to think innovatively. Okay, so they started pouring the concrete inside the plastic formwork, and then they are finalizing and extracting the concrete skeleton from the form, and then we have a textured structure, very beautiful structure, and then the fabric is just tensioned around this structure, and then with some paint isolation for water, so they can use it inside like a river, and then it is a live boat in action, and it is just a concrete structure. So can you imagine a concrete structure in action in a river like a boat? It is totally, from my point of view, I can see it, yes, it is an innovative idea that can be designed by an artist, but it is totally like a structural way of bringing the ideas into real life. So we need to learn more about structure. And if are talking about the structures, I have to share some like knowledge. There is Karamba, and Karamba is a grasshopper plugin, and this is a well-known structural plugin in Rhino and Grasshopper, and you can have it, with a very it is not expensive in an educational license, and it has a very interesting features. So you can design an innovative structures, a well-studied structures. Okay, this is the first one. Karamba, it's a structural plugin, and there is Amoeba Grasshopper. It is also a structural plugin designed by Professor Mickey Exie in Melbourne. And using Amoeba, it is doing a topology optimization, and how you can optimize topologies, and having a very interesting just a minute, and have a very interesting structures using this Amoeba. And if you go for the website, you can have a very interesting videos and so on regarding the Amoeba. I know Professor Mickey Exie personally, and he is, very innovative. You can check the website later on for Amoeba, and this kind of structures, it can totally be done on Amoeba. You can use the structural way of optimizing the surface for designing the surface itself. So it can be not just I design the architecture and then look for the structure, but I can be doing the form generation in the architecture by using a structural way of form finding. I can use a structural form finding technique to have a final architectural technique. Okay. And there is also a kangaroo. Kangaroo for Grasshopper, it is not a structural, but it is a way of doing a physics simulation. So using Kangaroo, I can do a physics simulation, simulating my own structure regarding the technical capabilities of the material in real life. And this is how I can have a surface considering the material capabilities and limitations. So I can make sure that my designs can come to real life after that. And this is how you can mimic and simulate tensile structures, fabric structures, and so on. Um, okay. Fahmi just sent me a message that my internet connection wasn't stable for the last minute. Can you hear me well?
Yeah, yeah. We can hear
Yes,
you.
sir.
Yes, sir.
Yes,
Yes, sir.
sir. Yes.
Okay, thank you. And now moving forward. Moving forward, I know the first structural idea we learn at the school is how to design a building using a slab and column. Um, in my school in Cairo University, they teached us in the first year how to design a building by considering a column, a slab, and a beam. Yes, this is a conventional way of thinking of a structural system. Let's go for some images. Column and beam structure system. Yes. At our first year, our professors used to teach us how to think regarding the structure. We should thank them, you know. I'm so thankful for my professors because they, when I was a student, I used to ask myself why they are wasting my time. I'm an architect. I'm not a structural engineer. Why they are wasting my time? Why they are teaching us how to consider a slab and column while designing a building? Why to consider the structural limitations while designing a building? This is how I was thinking, like in my first year. But now I joined the architecture school, architectural engineering school in Cairo University in 2007, and now it's 2021. I remember that, and I was wrong. From my point of view nowadays, from my point of view after my research, considering the structural aspect is very important. Actually, after the coffee break, I'll share some of my projects here in Cairo. I designed a lot of projects, and lately I designed the Grand Cairo Opera in the new capital, and the structural engineer, he is a very important person in the design process. He can change your design for something very innovative, or he can just destroy your ideas. And to make sure that your ideas will come to reality, and it will be, it will be a working structure. It will be a real structure system. You have to consider every structural aspect. You have to consider the material capabilities and so on. Okay, but now let's stop for a minute and then think of, in the conventional way of doing a conventional building by using a column, a beam, and a slab, you can have a structure like this. They used to have like a formwork and then start with the column, with the beam, and then the slab and so on. But now we'll discuss other idea. Now, using the computational tools, it is not like a column and slab and a beam. It's now like an assembly. What I mean by assembly, it is now like, the building is I can see the building like it's a living creature. It's like it has organs. And let's see the video. The video is so impressive. Okay, they started by building and thinking in a mock-up. They started by like thinking physically in a maquette and doing the 3D printing, and then assembling these pieces together and looking, how the final can be. And now we can see here it, this can be like a structural optimization for the study. This can be like the form generation based on a structural limitations. This can be a structural, this can be an architectural design, architectural system inspired based on structural limits. And now they are like optimizing. And here we can see like this is rhino and this is grasshopper and this is something structural where you can see like the loods and so on. It is, you know, it looks very interesting process. Firstly, they started like 3D printing a very small maquette, a very small mock-up, and then they moved for a bigger one. Now they have this like enlarged maquette, so they can like look for the final project. They can have like a trial process of how the assembly can be done, and they can discuss the ideas together. They can look for the future, and then these futures, this is a digital simulation of the idea, and then they started the 3D printing. I believe most of us had an experience with 3D printing, with plastic printing. It is available. I hope it is available in India. It is lately available in Egypt, and some students and a lot of students actually can reach these kind of technologies. So they started like 3D printing now. We are seeing now, this is a 3D printer, but what we are seeing now, it is not a plastic printer. It is a sand printer, and it is a very large sand printer. They are doing a 3D printing for something well known now. What is it? This is a kind of powder. We can say it's a ceramic printing. And just by watching the video, we can see like this is a kind of powder, like let's say ceramic powder. And then this ceramic powder, this moving part from the machine is injecting a kind of material. And this, we can see here, you know, this is darker color. It is just where the material is injected. It is solidifying this kind of powder. So it transforms the powder into something solid. And this solid will be located where the injection is happened. And now it is like this machine, it you know, it adds a layer of the powder and then injects a solidifier, and then other layer of powder and then injects a solidifier, and so on. So it's a layer of powder and then injecting a solidifier, other layer injection, other layer injection, and finally we'll have our 3D printed part beneath this kind of powder, and then we can just take it from, as we can see. And now they are taking the 3D printed piece from the powder, and this is a 3D printed formwork actually. They are printing the formwork, and this is now they are the supportive steel structures that will support the formwork. And this is, let's say, a CNC, but it is not a CNC actually. This is a prism of a laser beam. It is a laser beam, a very hot laser beam that can cut steel. And now they are, you know, like preparing the supportive steel structure that will support the 3D printed formwork together, so they can bore the concrete inside. Now they are doing the assembly between these 3D printed pieces and the structure, the steel structure as well, the supportive steel structure as well. We can see the formwork. This is totally an innovative formwork. It's a formwork from the future. It is not the conventional way of a beam. This is not just a beam. it's a beam and a piece from the slab. We'll see forward. And now they are finalizing this formwork using a fiberglass and a shotcrete with some adhesives for a first layer, and then they will pour the concrete inside after using the supportive steel structure. Yes, this is the pouring process, and then they take off the steel structure and the formwork as well. This is the formwork, the 3D printed ceramic formwork. He's peeling this off now. And finally, we have a 3D printed concrete organ. I prefer to describe it like an organ. And these pieces are assembled together to have a final innovative surface. And this is like, we can say it's a beam and column structure, but it's an innovative beam and column structure. It's a beam and column structure from the future, from my point of view. Okay, and then moving forward to discuss more ideas. More ideas from Professor Philippe Bloch group. And if I mention Professor Philippe Bloch, I have to mention his innovative exploration using compass, Bloch group ETH. And compass is an open platform, open for everyone to work on designing this kind of pre-tension surfaces. It is totally open, it's totally for free, and everyone can reach Compass on his website, on Professor Philippe Bloch website. And we have a lot of discussions with him in Digital Futures. You can reach these discussions on the website, on the YouTube channel, and look for the ideas. And on the Compass website, you can find a lot of tutorials and libraries, packages, and so on. You can just check the tutorials. No, I just checked it yesterday. It's available. It is there. Ah, yes, yeah. I'm sorry. You have to go for the Compass website. It's website. Yeah. This is a Professor Philippe Bloch website, but this is Compass website. Its own website. In the past version, it was like a closed version, but now in the newer version, he just published. It is totally for free, available for everyone. So if we go for tutorials, you can find a lot of tutorials regarding how to use Compass. Okay, and Compass is totally for free. And using Compass, you can design a pre-tensioned surfaces. And this surface is what we are going to discuss now. We are going to explore how they constructed this surface, how they designed this surface, and the technical specs of this innovative surface. Let's look for the video. Okay. Yes, I have to stop here. This surface is 3 centimeters to 12 centimeters thick. Can you imagine a massive structure like this one, and it is just 3 centimeters in some points, just 3 centimeters, and maximum 12 centimeters. I remember in the school they teached me every concrete structure is 10 centimeters as minimum. But now using Compass and by Professor Bloch research, it can be like just 3 centimeters. Okay, let's go for the technical details and how this massive interesting structure is done. Okay, it is in 80 edges Zurich, and as we can see, it is very high structure, and it is like they have edge beams, they have like a supportive structure. This is how it is constructed, but the final structure is just this shell, okay? And some of these is inside, we'll see further. But now they have like an edge beams, they have a supportive steel structure, and then there is a cable net inside, tension for a pre-tensioned structure. And then there is a fabric shuttering, there is a fabric, like, it's a fabric, it's like a plastic fabric tensioned on this cable net, and a tensile reinforcement like a metal net, pieces of metal net connected together for reinforcement, and then the concrete shell. Let's see further. And now they have, like, I remember when I visited Shanghai in 2019. I remember Professor Philippe Yuan Ward. He said to me, you are working, he said me, Hasab, you are doing a lot of research in the American University in Cairo. But you are working just with architects, and this is why you are doing too much effort and spending too much time, because all your team is just architects. But they and ETH and what he is doing as well, Professor Philippe Yuan in Shanghai, they are not just architects in a research group. They are architects, structural engineers, material engineers, mechanical engineers, and so on. So every innovative research should have these disciplines, should be like interdisciplinary. A lot of disciplines, a lot of different perspectives should work together so they can make a dream something real. And now they had a contractor working with them on the research, and he started with a pre-tensioned structure, and then this is a fabric which is prepared like we are seeing now, and then this is a reinforcement. Yes, let's stop here and go back. This black fabric is the reinforcement, and this white fabric is what is tensioned on the pre-tensioned structure. We have this pre-tensioned cables, and then the white fabric, like to make it a continuous surface, and then these black ones for reinforcement, and this is the simulations and so on. This blue lines, blue structures, is a metal structure, supportive metal structure for the whole surface in the construction process, but it does not exist in the final product. They take it off, and now this is a kind of shotcrete. They starting like shotcrete everywhere on the total pre-tension structure. Yes, shotcrete. Finalizing the surface and then taking off the pre-tension wires. So they have a pre-tension concrete structure. As we can see the final product, it's very high. If we go back like for a few seconds, we can see a human standing there, and the structure is almost double the height. I believe it's around 5 to 6 centimeters height. It's very high, and it is just 3 centimeters. Can you imagine a double curved structure, 6 centimeter high, around 6 centimeter high, and it is just 3 centimeter thick in some points? It's very innovative, and it is made in 2018. We can find, on Compass, how we can make something like this. And Compass is a form generation way of doing, form generation method based on structural simulation and analysis. Okay, let's move forward. And now moving forward, I believe we need more like a public experience. In our communities, if I can say in the Egyptian community, they still prefer, some clients still prefer the classical architecture, because this is what they can feel physically. But how we can take the public audience to the next level, how we can take the public, let's say, customers, how we can take our customers, how we can take our future clients, how we can take everyone for a futuristic step. This is by constructing, let's say, exhibitions galleries for everyone, so they can go and look for the structure, the innovative structure. They can, touch it. By touching the material, you can feel it. You know, this is why we are just spending money in having this kind of technologies, like let's say iPhone. When I have it and feel the material and its technology, the strengths and so on, I prefer to have an iPhone. And this is how we can take the public to a next step. This is how we can take the public for for the step when they ask for a computationally designed structure. We'll discuss further a lot of ideas I propose here in Egypt to be computationally designed. But yes, I understand the financial situation in the world, the financial situation everywhere is like a constraint, but we still have, and we still can do it. We still can think of how we can optimize the material, how we can do it like very cheap. I have 3 running projects now, and one of them, like, it's an art space, and Fahmi is working with me in the project. It is very innovative, and we are looking, while designing, we are thinking of the structural limitations. We are thinking of the material experience of the user and the assembly process. We are considering all the aspects just to optimize, financially as much as we can. Okay. This World Forum is very interesting. But as I mentioned before, I'm just getting these videos from YouTube, so I'm not doing any kind of montage. So the copyrights is just for the people who uploaded these videos to the Ideas Lab or whoever this one is. Okay. Let's go for the future. Okay. I don't know if you can hear the voice of the video, but I'll try to do my best, like in saying what he's doing. Okay. He is discussing the idea of construction industry in the last few years, and how the material and structural capabilities can be a game changing in the future. How studying the new materials and new construction techniques can change our future. And what can be done in the future using this kind of materials and this kind of structural techniques and this kind of technologies, how we can use these technologies for building a better future for everyone. If you remember, some slides I shared later, they use this kind of very massive 3D printer. And this is one of the largest 3D printer in the world. It is a ceramic printer. Now he is discussing the resolution of this printer. And he is discussing the idea that every architectural building is just a living structure. It is a living organism. It has a lot of organs inside. And actually he's telling the truth. Every architectural building is like it is like a creature which have inside a lot of organs, a lot of mechanical considerations, a lot of electric considerations, a lot of, we had to design using and considering the AC conditions system, lighting systems, and a lot of, if you designed a very beautiful classical structure without considering the technologies and the requirements we need nowadays, like the ventilation system, mechanical ventilation system, and so on, this kind of can destroy your design if it is not considered in the beginning. And now he is taking us a step further for something very innovative, very innovative. Yeah, I would like to move forward just for a few seconds in his futuristic talk and then stop here and say, Subhanallah, subhanallah. This is like it's a bone from your body. And when the architects would like to think of the future, they started studying their bodies. And from my cultural perspective, we had, a very old phrase that mentioned by Imam Ali. He mentioned وَفِيكَ انطوى العالم الأكبر. And this means if you look in your body, if you look in yourself, you can see a very innovative structures. You are a very dynamic creature who can move in everywhere. You are like a very innovative structure. You can respond, and you are, your weight is just 60 kilograms. I am 60 kilograms, and I can lift up to like 50 kilograms. And this is, if we are like just thinking structurally, this is not applicable. If we are designing a building, you buy the robotic arm weights around, let's say, if the robotic arm weights around 100 kilogram, it can lift like 20. It is 100 kilogram dead structure, and it can lift around 20 kilogram, just 20 kilogram. But you are a living organism who is 60 kilogram, and you can lift up to 50 kilograms, something like this. Because your body, subhanallah, is an innovative structure itself. So the architects, the structural engineers started to study the body, the human body, the human bones, and how Allah optimized the bone itself, for the creature, for the human. Yeah, and then they got an innovative idea of how to optimize the material, and the architectural design can be inspired by a structural idea. And this is how Amoeba is working. I have to mention again Amoeba, made by Professor Mickey Exi. Amoeba is a structural optimization plugin, and using Amoeba, you can, I think we can, look for some videos. Yes. Using Amoeba, you can do a topology optimization. It is mimicking how the creature, Allah, just optimize the bones in this innovative structure, in how we are operating and working, and with very few steps in Amoeba, you can, generate and optimize the structure. I have to move just forward, and then with some slides, he changed some numbers, and these numbers are manipulating an innovative surface on Grasshopper. And then he's doing, he's preparing the surface for the structural optimization. I would like to see the optimization. Yes, yeah. We'll skip the Grasshopper part, We need to see the topology optimization. And now he is optimizing the surface. Yes, he is optimizing using some topologies, some inputs, and so on. And this idea of topology optimization can be taken further for an innovative, as we can see, it is like optimizing a topology. It can be like a bridge, it can be a living structure, it can be a drone structure. You can do a lot of innovative designs, and do your architectural form based on a material intelligence and structural aspect, optimizing the topology. And all of these ideas just coming from your bones, just coming from just looking on how you are, on what you are as a human, as a living organism and living structure. And going back to the structural and architectural systems, we can see an innovative structural implementation. I'll move this forward somehow to save time. Yes. After the 3 printing. Yeah. Yes. And now, if you look in this as a conventional slab that can hold someone, it will be like a 15 or 20 centimeters depth. But now using a topology optimization, it can be reduced 80%. It can be 80% reduced from the material. So the dead weight is like 80% reduced. And this is a real image. It is not a digital image, it's a real image. In Shanghai, 2019, Digital Future fabricated a bridge, metal 3 printed bridge. In 15 days, they printed a bridge, a metal bridge, and it is structurally optimized regarding the topology using Amoeba and some other softwares. Yeah, he just mentioned they used the algorithm that is the same as our living organisms, the same as in bones, okay, and so on. And then moving forward more, it is not just a structural optimization. It is more a living organism, yes. At the beginning of our discussion, some of our friends just mentioned the architectural buildings, the architectural form can be a living organism. It can be like a breathing. It can be like, with organs. And considering some material capabilities, considering some material physics, we can see this kind of, My professor Sharif Murat has a published papers regarding these material capabilities using wood and so on, and how it bends based on some, based on the percentage of water inside its fibers and so on. I can share this paper later on if someone interested. Okay. And now we can see, this is not moving using some kind of electricity, and this is not a kinetic architecture. It is a responsive. It is totally responding. It is a material intelligence. It is totally moving based on the ratio of and percentage of water vapor inside the fiber of the wooden layer. As we can see now, it is opening and closing based on. And why this is totally innovative? I'm totally against the idea of designing a facade, building facade using a kinetic structure. I know there is a concept called the kinetic structure, and using this kinetic structure we use a lot of motors, a lot of wired connections and so on. And the kinetic structure, from my point of view, it is not helpful. It looks like I'm living in a magnetic field, but designing, considering the material intelligence and considering the nature capabilities like this project, we can design a very positive structure that is totally, very helpful for our bodies, for our lives, very positive and so on. And this living structure, living organs are made by Professor Akim Ming. Okay. And this is a video from an exhibition, from their exhibitions. You can just check their website and you can see a lot of opportunities and capabilities they are doing. They have a department looking for the biomaterials and how they can implement these biomaterials into a design methodology and form finding technique. and so on. You can see the wooden layers just moving, expanding, and bending, and so on, based on just a water vapor. So, it will be like very dynamic along the day hours and along the seasons around the year, and just interaction between the material and the weather, between the material and the ratio of the water in the air, water vapor, and so on. And moving forward more, going to uh, University of South California, and fabrication, from my point of view, my comment on the video we are going to see, is just a mindset. It's just on how we can do and how we can do. What I mean, let's see the video. Okay. There is a missing video here. Okay, I'm sorry for this. Um, this is something different. Okay. Okay, yeah. See, I'm sorry. Yeah. This is a video. Yeah. Okay. Yes. What she just mentioned. I'm asking, can you hear my voice? No, I'm sorry. Can you hear the video voice?
No, sir. No, sir.
Okay. So what she mentioned, what she was saying, she is asking why humans should should adapt to architectures. Why not architectures adapt to humans? And then she is asking herself why architectures can't be moving, why architectures should be static. Yes, like the static architecture I'm living in now. Like the static architecture you have, like your home. Why we are designing a static architecture? Why humans have to adapt to architectures and not the architectures adapt to humans? And then she is thinking of biometals, using some sheet metals. Yeah. Some metals can, like it is, what she just mentioned is what we are seeing, It is two layers of a material, two layers. One layer is like, let's say, it is more, had more strength than the other layer, and then it expands more. So it bends, like as we see it. When it heated, yeah, they are using the thermostat material and the design itself and producing the metal sheets. The application of the material is totally inspired by how these material are interacting and responding to the heat changes, and then it can be used like for a shading device. Just the sun movement, the sun heat can change how this metal interact, how this metal moves, how this metal changes. Yeah. Wow, it is 14,000 pieces. And she is working on how these kind of thermal materials can be used in innovative architectural design and so on. And the professor name is Doris Kim Song. Yes, you can take it in a note and then do some Google search for her. You can find very interesting and innovative ideas. She is working on a positive, interactive structures. Okay. And then moving forward, fabrication is a mindset. This is my quote, this is my way of seeing the fabrication process. How to do what can't be done. Yes. If we are looking for the future, from my point of view, I'm an architect, but actually I'm not just working as an an architect. I had a lot of experiences. I had a lot of involvements in like jewelry production. You know, I involved in a lot of jewelry design and production and fabrication, and involved in yacht. Let's go for Google. It's a better way of connection and sharing ideas. Yes, jewelry design using grasshopper and rhino and jewelry fabrication. This is, as I mentioned, it is how to do what can't be done. Fabrication is totally a mindset, yes. Okay. This kind of innovative designs can be done using rhino and grasshopper and so on. But the point is, the innovation is, it is not just the design. It can be fabricated using the same software. Because using rhino and grasshopper, it is totally an Urbis modeling surface. It is an Urbis modeling equation. So it can send data to machines. So you can do like a 3D printing, you can use CNC metal milling and so on for jewelry design. And then, let's say, using rhino, you can have also an innovative ideas. And yacht design, I had a previous experience in two yachts, one in Morocco and the other one here in Egypt. And we are working, it is a running project, it still exists. And it is totally designed using Rhino. And then the digital fabrication will be like using CNCs, 3D printers, metal welding and metal bending and so on. And using Rhino and Grasshopper, it is not building architectures. You can build the future, whatever, what imagined future you can think of using this kind of software. So learning the software is like learning how to talk, how to speak, how to use a language. Software is a language, and software is a window on the fabrication. When you ask me to do a fabrication project, definitely I will not know how to do it, but I just have to take a break, bring a cup of coffee, and start thinking on how this can be done. This video is so innovative. It is Rahmatullah alayha Zahadi designed like a shoes, and they are willing to do like a mock-up model, scale 1:1 shoes, but not a smaller one, enlarged model. And this is how they have done. Okay, they started like with having a metal a wooden sections. Now you can see a wooden sections, and then they bring this kind of let's say foam board. And this foam board, like they extracted the extra pieces, subtracted from it the extra pieces, so they can have like a foam board between these wooden sections. And then this foam board are just subtracted more and more to be softened, to be like a continuous line, continuous curvature. They being softened, yes, after they removed the extra pieces, and then they starting yes, finalizing, and they are softening the surface manually and using some very very basic machinery for softening these foam boards. And then they started using epoxy. Let's say it can be epoxy, it can be like a glue on the foam board, yes. And they used it to fix some fiberglass. This white fabric is a fiberglass sheet. They used a glue. Let's say from my experience, it can be epoxy. They used epoxy to fix this fiberglass, and then they started, like finalizing the surface. So it can be like a car paint. They are doing, they are preparing a car paint layers, and then finally, yeah, they finalize the surface as if it is a car, um, using the car paint layers, and now it is a final, well designed and fabricated surface. And this can't be done using any other software, but using the proper softwares and thinking innovatively on how you can design and construct something that can be done. Moving forward more for a fabricated pavilion, okay, and it is designed and made in France, as I remember. It is a wooden pavilion. It is totally designed on Rhino, and then they used the grasshopper for data extraction. But I have to mention they had a very innovative CNC, a very advanced CNC, which can cut on angles and so on. They cut pieces, they simulate these pieces, and using the software you can extract the pieces, number tagged with the connections prepared and so on. This is how you can have a kind of a simulation for the structural and for the assembly as well. On-site assembly, they are, like simulating this assembly, and assembly is the process itself on how they are, getting these pieces together to have a final fine-tuned surface and pavilion as well, presentation. And we should be very thankful for these softwares, because we can simulate, we can see the final product from the beginning, from the start. So on site we don't have a sudden problems, because every step is well studied and simulated digitally before going on site. And then they went for cutting and data extraction, so on. All these structures are extracted using grasshopper and tagged and so on. And this is a simulation on how the CNC will be doing its job for cutting the edges and preparing everything and so on. And I have to mention again, they had an advanced CNC. It can cut in angles, and as well it can automatically change its head. Yes, now it is changing its head. Yeah, some countries believe in using wood, so they invest more in wood. So it's fine if you don't have this kind of machinery in your country, because it's based on the need. We have CNCs here in Egypt, a lot of CNCs with a big and large sizes, but not with like these kind of adaptive changing tools and so on. We are not a country with a lot of woods and so on, but France, maybe they had. Okay, and now they fabricated and assembled, let's say a tile, let's say a module, and after assembling one module, they are going to lift this module and then assemble all together. We can, yeah, okay, we can say they have a pieces, and then these pieces are assembled together for a module, and this module assembled together for a whole structure. Okay, and this whole structure is totally innovative, as we can see. It's totally just a wooden structure, and these wires for a pre-tensioned structure, so it can keep it together. It can keep it together. It is just a structural consideration. Okay, and then moving forward, is it total a computationally designed and automated fabrication, or it can be just assembly? Yeah, it can be just assembly. It can be just an automated assembly. Yes, and now we can see this innovative surface. Lately, in the last months, I saw some very innovative structures in India, which was made using the same technique, the same brick structure, the same brick assembly, you know, and bringing together just very small bricks. And in a very innovative way of putting these together, we have a very innovative final surface. It is just a very small members, very small bricks. And other idea, how we can imagine the future of designing and building, let's say, a tower. But this is just a mock-up, but it is again based on just a very small element like a brick. And this is how it can be done on site. If we had a robotic arm, it can do the assembly. It will bring the brick tile and then put it together based on coordinates, based on form generation on Grasshopper and so on. And you can find a lot of plugins on Food for Rhino. If we went for Food for Rhino, let's open Food for Rhino. Yes. On Food for Rhino, you can look for plugins for Grasshopper. And yes, nowadays a lot of plugins are available for everyone for free, thankfully. And if we go for Food for Rhino and then went for some CAM or digital manufacturing, for CAM, you will have a lot of plugins. And if we go, you can find some for structural plugins. You can find some for robots. You can have some for physics and programming and prototyping and so on. So on Food for Rhino, you can have a lot of plugins which help you on simulating what you can see now. Okay, and then moving forward, you can generate a lot of ideas, and you can find on Food for Rhino as well a lot of ready plugins, ready definitions, Grasshopper definitions. Yes, regarding these kind of ideas, the wooden and brick walls and so on. You can just check the website. You can find a lot of all of these are ready script. You can download the script and you can use it and try it, and you will find something very interesting. And you can use like virtual technologies. You can use AR technology, virtual technology with the robotic for assembly and so on. And I would recommend for you to check later on Suminham. Suminham architect. Yeah, I know. I believe I'm writing her name. Suminham. Yes. Suminham. She is Chinese, but she is the most innovative engineer. I have to say she is an engineer. The most innovative engineer I have ever seen. On Digital Future, we have a very interesting discussion with her regarding this project. You can check later. And if you are interested, just send me a message. I'll send you the video. This is designed in Rhino and Grasshopper, and then using some AR and VR technologies, you can wear this headset and you can see using AR technology the annotation in the space. You can see like tagging. You can see the wooden structure guideline, and then you can do it manually. It's not manually, but it is guided using AR technology. So this man don't know where to do and what to do until he can look through the AR glasses, and then he will see the tagging, will see the guideline, and then he start fixing these wooden structures. It is totally done by human hand with no robots. It's just man-made structure, but with the help of digital and virtual AR technologies. And this is how they have this very extremely innovative structure. And we can check, yeah. Very innovative This is a formal video of the structure, and it is totally designed using Rhino and Grasshopper, but fabricated using human hand with the help of AR technology. This is virtually construction process. First step, doing the foundation for the structure. Wow, some internet lagging, I'm sorry. Some foundations, preparing the wooden sheets, and then timber loops, timber boards. These timber sheets are being prepared, and with the help of AR technologies, they are taking it into real. Yeah, they are doing some kind of um, they use this plastic sheet, yes, and use a water vapor technology to to push the water vapor through the fibers of the wood, so it became so flexible, and then it is heated and they extract the water from inside these fibers. It had the shape like doing cooking a cake. Yeah, AR technology, the tasking and the guideline, and doing it like by human hand. But it is, yeah, it is totally innovative. It's totally from the future. Yeah, bending, having a lot of beautiful wooden details, finalizing the surface, and then metal brackets, preparation process using AR technologies on site. He don't know what to do and where to do until he wear these glasses, AR glasses. Preparation on site. Everything is happening based on AR system. Construction process and assembly, it is guided using AR as well. It's totally human-made system. Yes. It is like playing a game in real life. Yeah, I became so excited when I think about an advanced structure and a construction process, how we can design, how we can build our futures, better future for everyone. Very innovative and advanced. Very exciting building, form and structure. Okay, let's go again back to my presentation. This is very advanced and it is made using the same technology, but now we go back for the brick technique, the brick module, and how using this kind of technologies we can do assembly for an innovative surfaces that is totally designed from a very linear element, modular element. Okay, but now moving forward for a very different technique, special printing. Special printing, it is a 3D printing, but now they control the heat. They can play with the material in the 3D space. Okay, they can do the 3D printing with fewer supports. Later on in our future workshop, yeah, I believe we'll have a future workshop with you all, and that workshop we can have, and then we can do nesting. And by nesting, this is how Akaming had done a lot of innovative structures like these ones. If we go for, maybe someone can ask me why, Hasab, you are going for Google every time, because there is two way of teaching. No, actually, I'm saying it wrong. There is teaching and learning. I believe more in learning more than teaching. So it is not just a lecture. I'm not just giving you some technical advice. I'm just doing my best She firstly experimenting with very small structures, and then she is using what she learned. It's like a form. It's like a form generation based on or inspired by materials. You have the material, you do experimentation based on the material. So you know more about the material capabilities, you know more what the material can do, and you know more on its physical limitations. And then you consider all these aspects and go for like a mock-up model, very small model. So you can have a physical experience with these aspects on a design, and then you learn from the process and from the experimentation itself, and you go back for the material statistics and material physical experimentation, improve the thickness, improve the curvature, and so on, and go back for a mock-up and test it again until you have an applicable structure with these factors and considerations and variables. And when it is real and it can work, you go for real, do the building. So let's conclude what I had said, answering your question. If you ask me to do a future design, futuristic design, using a biomaterial, I'll go for a material and test this material and learn from its capabilities. And when I learn from its capabilities, I'll do design considering these capabilities and this knowledge. And when I do design considering these physical capabilities and knowledge, my design will be working with this material. So it considers the material. And by considering this material, I'll be working with the environment. This is the first approach. Let's go for a second approach. The second approach, we can do like a 3D printed building using clay and wasp. It's I remember it's an Italian project. Let's say wasp clay printing. Yes. Yes. Wasp clay printing, as you can see now, this is a real-time structure that is printed using clay. Also, this in EAC, Wasp and EAC, they printed a clay structure. So the second approach, you can just go for the material and do 3D printing using this material. So you can print a whole structure using clay. And this is how you can print a sustainable, environmental friendly structure. Okay. For the third approach, let's say a third approach. In the third approach, you can do structures using wood. You can fabricate using wood. There is a lot of running projects in Finland to do structures totally from wood. So they invest in planting a lot of trees and have running projects just on wood. So this is a sustainable process. This is a third approach. If we look for a fourth approach, I'm just thinking, I'm just looking forward. So you can just do as I'm doing now. You just can think of a material and then think of its capabilities and then think of its implementations and design based on this experience. You will be doing an environmental friendly building. And the fourth approach is to design based on environmental simulation and environmental optimization. From my point of view, I'm using Diva. Diva is an environmental plugin you can use for an environmental optimization process. So you can design your building considering the heat, the light, and the natural ventilation. And this is how you can generate a building considering the environment, but it will not be a material friendly building, but it will still be an environmental friendly building. Yeah, yeah. And still there is a lot of ideas, approaches. You know, you can just think for how you can do it, and you will find a lot of ideas. I hope
Yes,
I answered
yes,
your question. Yeah,
yes. Thank you, sir.
yeah. Welcome.
So any more questions?
Hello? Hello?
Yeah. Yes.
Sorry, I can't hear.
Ah, okay, okay, okay. Yeah, yeah, yeah. It's fine. It's fine. Yeah. Okay. Do we have any more questions?
I think on a guy, it's called a good guy institute, Bala Murugan. Very wonderfully, you can ask the question. If you want anything about this,
Yes, sir.
any doubts, maximized doubts, Mrs. Suman, design.
Okay,
Ready to
sir.
answer whatever, if you wanted the question for how she was starting the design, how she was implement the design, how
Oh,
she was using the algorithm to using this particular pavilion design. I'm ready to answer.
Okay.
Ready to
Yes.
like
okay, sir. That's great.
Uh, okay. For this specific question, I prefer to take a note, and I'll show you from my own experience. You know, I have the feeling that a lot of our friends here are interested on a material-based experimentation, a material-inspired approach. I'll try to show some of what we had done, like for a material-inspired. Um, but also I have to check. I don't know if it is shared on my LinkedIn or not, but we had a published paper with my professor, Dr. Sharif, on our material experimentation and how we do, like, how we think of and how we teach the students to get inspired from the materials to generate their own designs. Okay. Academia. Um, Ahmed Hasab. As I said before, I prefer learning than teaching, and this is what I'm trying to do now. Yeah, yeah, rule-based. Yes, I have 4 published papers, but you can find now just 2 on academia. Yes, just go for academia and check Ahmed Hasab. I'll copy the link and let's see how I can share that link. Um,
just you can check the right side on top, right hand side,
yes,
chat
I
room.
would like. Yeah, I'm just yeah. I just I don't see it. Yeah, and just where? Ah, yeah, 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 yeah. I found it now. Yes, okay. Chat room. Yes, chat with everyone. Yeah, this is the link now. Yeah. Okay. So you can just check the link on the chat room. And this paper, through the paper, you will see how we used to implement the material experience with the students. We just firstly go for experimenting the material and see the material limitations and learn from its physical capabilities, and then we start implementing these physical capabilities into design process, not just design process and fabrication process as well, and how the students are implementing, you know, their designs and their material explorations, form, fabric, and so on, into final outcomes. Um, and on issue, I remember, um, if we go for issue, and AUC. AUC. Arc 473. Yes, yes. This is we had a lot of yes digital design studio and workshop. Yeah, this is our studio on issue. I'll share the link as well on the chat. You can check our students, my students' portfolios. So this is a teaching experience we used to do. You know, if just check these portfolios and you will see how we are implementing the material experimentation process into the learning outcomes. And we can discuss further this in the second lecture. You know, now you just in the break, just take a look and then we'll I'll discuss later all of these or most of these. I'll select some of them, just run them and discuss the ideas and so on. And I'll bring some of my own designs uh, while being a student in the university and share with them. Yeah. Okay. Do we have any more questions before taking a coffee break?
I think it's a lunch break, Mr. Hassan.
I think
Okay.
it's 12:15 in India time.
For you.
It's still 9 a.m. here.
Nearby 9.
Yeah,
It's nearby.
but I can go for my breakfast. I can take my breakfast. Okay, so we can
Yes.
take a break for
Yeah.
15 minutes or 1 hour. What do you
One
prefer,
one
sir?
hour will be preferred, sir, because it's for lunch
Okay.
break. Yeah, yeah.
Yeah. Okay. Yeah. Okay.
Okay.
So we'll come back after 1 hour.
Sure.
Yes, sir.
Thank you.
Thank you, Professor. Yeah. We'll meet you at 1:15. Thank you so much. Okay.
Yeah. Thanks for you
Thank you,
and
sir.
for Chandra and for everyone.
I
Yeah.
I request all the students to be back by 1:15. Yeah, we will continue the session. Okay.
See you
Thank
all.
you.
Yeah. Yeah.
Alhamdulillah.
Mostly welcome. Yeah. مع السلامة. السلام عليكم.
Alaikum salam wa
Walaikum
rahmatullah.
salam.
Good afternoon, sir.
சார் ஜஸ்ட் மினிட் அசாம் லைனுக்கு வராரான்னு பார்த்துக்கிறேன்.
Okay, okay, sir. Okay, sir.
லைன் இல்லை ஒரு
இல்ல சார்.
பிரேக்ஃபாஸ்ட் இப்போ தான் இது பண்ணியிருக்காரு.
Okay, okay. Okay, sir.
Start. Hello, my friend, can we start? Hello, Azab. Hello. Hello, my friend. Hello. Hello. Yeah. Can we start right now? Can we start right now? The second session. The second session class. Yes, ma'am. Everyone is logging. Hello. Hello.
Sir, he got disconnected. Maybe he'll join now.
Yeah. He's online, sir, right now. Just a second. Let's read. 1 second. Was logging.
Ahmad Fahim sir is there.
Fahim. Hello. Fahim. Fahmi. Hello. Fahmi.
So good afternoon, students. Just please bear with us. Within few seconds, we will try to contact the professor and we'll come back to you.
Hello, Fahmi. 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 I'm sorry. Actually, I'm sorry, sir. Actually, he was having his breakfast just now. He's
Okay.
not awake. Actually, Fahmi is there. I think just a second. I was called Mr. Fahmi.
Okay, okay, sir. Okay, sir. Please, thank you, sir. Sir?
Fami, can you online? Yeah,
No, sir, it's no, it's me, sir. Any message from Professor Ahmed?
yeah, Azab is online. Yeah,
Yes,
sorry.
yes.
Yeah, it's okay. It's okay. It's okay. Fami.
Yeah.
Yeah,
Good afternoon, sir. Good afternoon, Professor Ahmed. Hope you had your breakfast.
actually, I'm sorry, Azab. You had your breakfast.
So can you hear? Yeah. I think it's you have to unmute your mic, sir.
Yes. I
Oh,
was muted. Yeah, sorry. So we
I'm
have
sorry.
everyone here. Yeah, yeah. No need to sorry, Chandra. It's fine. It's totally fine. Yeah.
Because you are breakfast.
No, it's fine.
It's okay.
Okay, let's start our second presentation. Just a minute. I'll share my screen.
Azab, actually,
Now, yes.
as usual, I was very happy with what is the explanation before. What is the digital fabrication? What is digital fabrication for the executed our futuristic design? I was very impressed because, as my personal opinion, I was impressed with your presentation. Very good for that. And future, if you don't know how many students are interested in those topics, but definitely it's very nice.
Yeah, thank you. Yeah. We are just doing our best, you know. It's my main goal today and tomorrow is to transfer knowledge. Mainly, it's not about teaching; it's about learning, and how we can help them by teaching them how to learn to improve their lives. So this is my goal for today and tomorrow. It is not about what I am sharing; it's about how to find what I am sharing and so on. This is why I'm just opening Google Share and looking for materials. I'm already prepared in my mind where I will look for and so on. But the point is to look for with the students so they can find it again and again and again forever. Okay, so let's start now. Now we have now means before the next break. Okay, we have three subjects to share. The first one is material based, about a very small experiment I had in my graduation project. And then the second one, I'll be sharing some of my projects and so on. Maybe someone would like to ask something. When I share my projects, my main goal while sharing my projects is mainly um, about what is done and how it is done. So I can just mention this is made using Rhino, this is made using Grasshopper, and this is made using TSP Line, and this is made using 3D Max, and so on. So the students can understand what can be done and using what, so they can visually understand the software and